Hello, Science 20s. Today is going to be a different lesson. We're going to do one question and then we're going to follow it along and we're going to try to figure out a way for me to also show you how to prepare this in the laboratory. So let's get started. So our example is going to be this. We're going to figure out what mass of solid copper 2 sulfate, CuSO4, we are going to need in order to make 100 milliliters of a 0.5 mole per liter solution. So let's start with the math. So first thing we're going to do is, well, we know this is going to be a volume, and we know volumes have to be in liters. So let's change this to 0.1 liters. This is, of course, a concentration, and our job is we are trying to find mass. So first step we're going to do is we have a concentration and a volume. So we have the formula C equals N over V. We have concentration and volume, so we're going to have to find moles. So we're going to move the volume up to the other side, and my formula is going to turn into N equals C times V. So we are going to take 0.500 moles per liter, and we're going to multiply it by 0.100 liters. And the number of moles I'm going to get is 0.0500 moles. Now, secondly, now that I know moles, we can use our second formula, right? We have moles equals mass over molar mass. And so our job is to find mass. And so we're going to move molar mass up to the other side. So we're going to have mass equals moles times molar mass. Now, our moles we just solved for 0.0500 moles. And we're going to multiply by the molar mass. Now, I shouldn't have to do this for you, but I will at least write down what numbers you're going to add together. So copper is 63.55. Sulfur is 32.07. And oxygen, we have 4 of these, so it's going to be 4 times 16, which means when I add all these together to get my molar mass, I'm going to multiply by 159.62 grams per mole. Work around my face. So I'm going to type 0.05 times 159.62, and my answer is going to be 7.98 grams. That is the amount of copper 2 sulfate I am going to weigh out in this lab. So what I'm going to do is I'm going to pause the video and I'm going to get us set up with, so we'll clear this, we'll move on to the next screen. And so in order to make this solution from copper 2 sulfate, I'm going to need, of course, copper 2 sulfate. I'm going to need distilled water. I'm going to need an electronic balance, some weighing paper, a stirring rod, a volumetric flask. I'm going to make 100 mils, so I need a 100 mil volumetric flask, an eyedropper, and a beaker. I'm going to pause the video and I'm going to get set up for how do we weigh something on the electronic balance. Now, to weigh something on the electronic balance, I'm going to hit the pair button. So the balance zeros, and it's going to be hard to put the zero because I'm talking over it. So the wind, you'll notice, is going to move the thing, but we're going to get it as close to zero as we can get. And I'm supposed to weigh 7.98 grams. So I'm going to put copper 2 sulfate on there until I get to 7.98 grams. Now that I'm at 7.98 grams, I'm going to transfer all of the copper 2 sulfate into my beaker. And you'll remember that I'm making 100 mils. If I'm going to make 100 mils of a solution, I'm always going to dissolve my solid in half that amount of water. So I'm going to take a rough guide at where the 50 mils is, and I'm going to pour that appropriate amount of water in there, and I'm going to stir this. And again, I'm going to be careful that I don't splash. If I splash, I will no longer have the 7.98 grams of copper 2 sulfate. When I'm stirring, I also won't lift out my stirring rod and set it down. Everything I have is going to be sitting here perfectly as I go to stir this thing. And we're going to pause the video. Now, I'm stirring and as you can see, it's all now dissolved. What I'm going to do is I'm going to be careful not to set down my stirring rod, because if I set it down and the table gets wet, I could transfer some of my copper 2 sulfate. And remember, I'm making up this exactly to a concentration of 0.5 moles per liter. So if I take this out now and drop any of this copper 2 sulfate, this blue solution anywhere, I'm changing the concentration. So holding this all together, I am going to pour gently into a 100 milliliter volumetric flask. Now, the one thing I want to point out on this is, on a 100 milliliter volumetric flask, there is only one spot where there's a line. This only measures 100 mils, and this measures precisely because it's got a skinny neck. And this neck, where we're going to see it, there's going to be a swoop here, and this dip, we want it to touch just barely on that line. That is called a meniscus, and we want it so that the bottom of our meniscus is on the calibration line. Anything below, not accurate. Anything above, not accurate. And so I am going to gently pour all of my copper 2 sulfate, my roughly 50 mils, into my 100 mil volumetric flask. No spilling. If we spill, we have to start again. If we splash, we have to start again. Now, if I take a look here, I need to know that all of this has transferred over. So what I'm going to do is, and why I only dissolved it in 50 mils is, I'm going to rinse all the rest of this stuff. So I'm going to rinse my stirring rod. Once it's been good and rinsed, I know all the copper 2 sulfate's off of it into the beaker. Now I can set this off to the side. I'm also going to rinse my beaker a little bit. And I can now transfer that into the 100 mil volumetric flask. And by dissolving it only in half the amount of water, I can rinse this a few times because I want to make sure every last copper 2 sulfate particle has made it from the beaker where I dissolved it into the volumetric flask. So I've rinsed it twice. You could rinse it a third time if you want. You'll notice there's some bubbles. We're going to do our best to try to get rid of these bubbles. Just little taps should normally get rid of them. Okay. And what I'm going to do is I'm going to fill this up. Again, we want to fill it up to the line with my distilled water. Always want to do this at eye level. Let my bubbles subside. Now, we're not quite at the line yet. We're a little bit below. We want to knock out any bubbles that we have. And we can see that there's a few. So we've got to get them to the top. And you can see that my solution is here, but my line is right there. I don't want to shoot water in with this anymore, because if I shoot too far and I get above the line, there's no way for me to pull water out where I know for 100% of a fact that I'm not taking copper 2 sulfate out. And remember, I need every bit of the 9.8 grams of copper 2 sulfate to make up my exact solution. So instead, I have a little bit of distilled water with an eyedropper, and I'm going to, at eye level, at exactly eye level, I'm going to put in this water until the bottom of the meniscus is exactly just touching the calibration line. Looks like I need probably 2 drops more. 1. Now, I don't know if you can see this because it's at eye level, but we want to make sure that that line is exactly that calibration line, the line across the meniscus just touches it. That means we're getting exactly 100 mils. Our last step, because this is now mostly water and this is the solution, we're going to put the stopper on. And we don't shake in chemistry because we don't know if this is going to react violently, if it's exothermic or endothermic. So we're just going to stop at the top and we're going to invert it. And we're going to let the natural bubble that's in this actually cause the mixing. So we don't do anything drastic, but we're just going to let the natural bubble of this. Now, you have made up exactly 100 mils of 0.5 moles per liter. Now, what we can do is we can take a empty beaker and we can pour this into an empty beaker because now we can use this. If I want 10 mils at this concentration, we can use it. Now, the thing about this is I'm going to pour it over here. And I didn't pick a big enough beaker, but it does just fit. Now, we don't actually have 100 mils in here, right? Because whenever I pour something out, I always leave a few drops inside. We made up 100 mils in a 100 mil volumetric flask because odds are we needed 50 mils or 80 mils or 90 mils. We don't make up 100 mils because I need to use 100 mils. There is no way for me to get every little droplet out of here. Kind of like you have a drink of juice at home, you take a sip, there's always that one or two drops on the outside you can't get. Same thing here. We always make up more than we need. So I made up 100 mils because I probably only needed 85 mils. Now I can choose to take 85 mils or 50 mils out of this. The reason I used this equipment was this was about me making a precise concentration of a solution. So when I buy a lot of solutions don't even come in solutions. They come as solids. So copper 2 sulfate came as this solid. You saw me weigh out. I can now, it's nicer this way because one, the shippers aren't paying for the weight of water, right? If I want a weak solution or I want a concentrated solution, I can make it myself. Now that I have the solids, if I want to make a 0.5 mole per liter solution, I can. If I want to make a 3 mole per liter solution, I can. I just have to do the calculations in order to do that. Hope you enjoyed the video. Thank you very much. Now, after doing the demo, I changed my mind and I really want you to write down the steps on how to make up a solution. So I've broken it down into 6 steps. This will also get the vocabulary words into your notebooks. So we're going to measure out 7.98 grams of copper 2 sulfate on that was called an electronic balance, and put it into a beaker. We're then going to dissolve it in 50 mils of distilled water or half the final volume of water. So we want it to make 100 mils. So we dissolved it in 50. Next, we're going to transfer my solution and we transferred it into the 100 milliliter volumetric flask. After that, we rinsed out and transferred all of our rinse water, including the water from our stirring rod, including the water from the beaker, and we poured it all in here. We then used an eyedropper to add distilled water until we filled up to the bottom of the meniscus on the 100 milliliter calibration line. And lastly, we stoppered and we inverted it. And then for us to put away, I just poured it into a beaker. Here is a picture of what we were looking for. When I look at a thin piece of glassware, and all thin pieces of glassware are considered precise pieces of glassware, we are looking so that the bottom of this meniscus falls right on ours. For us, it was a 100 milliliter calibration line, so that we're getting exactly 100 milliliters made. Thank you very much. I hope you found this lab informative.